Alright, in this problem we have a rational equation that we want to solve. So we need to find the lowest common multiple of these three denominators. So hopefully you recognize that x squared minus 1 is a difference of squares which factors into the product of the other two denominators. Right? That's going to factor into x plus 1 times x minus 1 if you think of this as x squared minus 1 squared. So the lowest common multiple, that is the lowest common multiple of those three denominators. So that's what we need to multiply both sides of the whole equation by in order to eliminate all three denominators so that we can solve it. So on the left, I'm going to multiply by the factored version, x plus 1 times x minus 1 times this whole thing, so times x plus 5 over x minus 1 plus x plus 4 over x plus 1. Equals, on the right side, we're going to have 8x plus 11 over x squared minus 1. Also times this, except you might as well multiply by the simplified version over here on the left, right? Just because then it's more clear that those cancel. Over here on the right, when we distribute over the plus, we're going to do this times this fraction. So when we do that, this x minus 1 cancels with that x minus 1, so we're only left with this x plus 1 times this numerator x plus 5, and plus, we'll distribute it over the next fraction. Here that x plus 1 cancels with this x plus 1, so we're left with this x minus 1 times that numerator right there, x plus 4 equals 8x plus 11. Okay, now we need to simplify. So this is it's now a quadratic equation because if we FOIL this out and we FOIL that out, we'll have x squared terms. So we need to get everything on one side and then maybe it'll factor. If not, we'll use the quadratic formula. Okay, so FOILing over here, we've got x squared. The outside plus the inside term is going to be plus 6x plus 5 plus, over here on the right, x squared plus 4x minus 1x is plus 3x. And negative 1 times 4 is negative 4 equals 8x plus 11. Okay, then we want to combine like terms. So let's see, I've got an x squared plus x squared is 2x squared. And I've got 6x plus 3x is 9x, minus 8x is plus 1x. Then I've got 5, minus 4 is 1, minus 11 is negative 10, equals 0. And let's see if that factors. So to get a 2x squared for your first term, those two terms are going to have to be 2x and 2. Let's see, we want the last two terms to multiply to negative 10 and add to positive x. Let's see, 10. If we broke it up into 5 and 2, that would might work if we put the 5 there and the 2 there, because then my outside term is going to involve a 4x and my inside term would involve a 5x. And 5 minus 4 is 1x. So if we put the positive here, then my inside term will be positive 5x. If I put the negative there, my outside term is negative 4x, which adds to positive x. So that works. So setting the first factor equal to 0 gives 2x equals negative 5, or x is negative 5 halves. And setting this factor equal to 0, we're going to get x equals 2. Okay, and then we would need to check both of those. Now I can check visually real quick. Neither of those is going to cause a 0 in any of those denominators. If x had been positive 1, that denominator would be 0, or if x had been negative 1, that denominator would be 0. So there's no problems there, but we do need to plug them both in and check to see that they both work, which takes a little bit of effort and time, okay, to check them, but you do need to do that as well. So that's how you solve that rational equation.